product and quotient rule. So here's where we actually start looking at the quotient rule. Just remember, quotient's just another way of saying fraction. Okay, basically what we have a formula here is if we're going to take the derivative of two formulas, two functions, f and g, f's on top, g's on bottom, then basically I'm going to tell you that bunch of algebra, basically things we found out, that here's the pattern. The pattern is if we're doing the derivative of a fraction, we take the derivative of the top one first, leaving the second one alone, minus the derivative of the second one, the bottom function, and leaving the top function alone. So once again, you kind of get in that pattern. We're doing the derivative of one piece at a time, but for the quotient rule, we have a minus sign and we have this fraction with a g squared in the denominator. So it's kind of like the product rule where we're doing the derivative of one piece at a time, but it's not quite because we've got a fraction and we've got those minus signs. And so where did those come from? So where did that minus sign on top and the power 2 in the denominator come from? Basically, I'm going to tell you this, that when you start with a fraction, f over g, we could rewrite that as f g to the negative 1 power. Now, what we can do then is do the product rule on this new expression. So we're doing the product rule on a rewrite of the fraction using the negative 1 for the denominator, for the power there. And then when we do the derivative with the product rule, we can work that all out, do a bunch of algebra, and guess what? It makes the fraction that you see on top here. So when we're doing the product rule on this expression, this is where the quotient rule is coming from. Okay, so that's the quotient rule in just a kind of very nutshell. Technically, at this stage, I can't really do the algebra to show you on this technique because I'm missing one derivative technique. But later on, if we're interested and we have time, we can actually look at it. So let's go to do some practice here. So if you feel that you've got the quotient rule already, all down, ready to go, then go ahead, hit pause, do these derivatives, and then come back and we'll compare. Okay, so for the derivative of the first one, basically what we got is the 2x minus 12. That's going to be my f function. The denominator is my g function, so that's 5x plus 57. So what I'd like to do, it's just a recommendation I have for people who are just learning the quotient rule for the first time, is I recommend off to the side, go ahead and find your pieces. We need an f, we need a g, we need the f prime and the g prime. So just go ahead and calculate that. So basically I labeled my f and g, who's the top, who's the bottom, and I took their derivative. Now I've got all the pieces. So then I go back to the quotient rule here with my 4 pieces and I plug those pieces in. So where I see an f prime, I plug in my 2. That's my f prime. Where I see a g, I plug in the original g, and then so forth and so forth. So what I like to do is make my pieces off to the side, my f, my g's, my f prime, g primes, and then just plug them in the appropriate spot in the quotient rule. So that's the derivative part. Next part is just kind of working the algebra, just multiplying that 2 all the way through, multiplying the 5 all the way through, and then cleaning up the like terms. And so in this particular case, the 10x is going to subtract out because of that subtraction there. And then that 60, do note that that's a double negative there, so it's going to be basically a 114 plus a 60. And so that's the steps for doing the quotient rule. Another example we have here. Okay, so once again, what I'm going to do off to the side, I'm going to label the top function as f. I'm going to label the bottom function as g. So I've got my f and g, and now basically just take the derivative of each one. So I've got my 4 pieces. I'm ready just to take those 4 pieces, go back to the quotient rule up here, and just plug in everything that I have, the pieces, in the appropriate spots. And this is what I get. So I'm just taking my pieces, plug them in. There's the derivative. I am done with the derivative. The derivative's done. But you probably have a professor that wants you to clean this up, so we're just going to do some algebra just to kind of clean that up. Once again, just distribute things all the way through, do that 21x to the 6th through, do the negative 12 through, and then multiply this 10x to the 4th through. And so when we do that, we get this expression. So I'm just kind of doing the multiplication, getting my results with the multiplication, and then remember for that second part on top of this fraction here, that minus sign is going to go to both terms. So it's going to make it a minus 30x to the 11th, and it's going to make it a plus 120x to the 5th. And then combine like terms where I can. So basically, the 30x to the 11th will combine with that 42, but it's a minus. And then the 120x to the 5th will combine to that 60x to the 5th. This becomes a plus 120, so that's why we'll end up with a positive there. So there's another example of the quotient rule. We do the pieces off to the side. It makes it nice and straightforward. Put the functions in the appropriate spots. The actual derivative, pretty straightforward. It's the algebra after that for cleaning it up. That usually is where students don't like. Okay, another example here that I'm looking at. Once again, what I'm looking at here is this vertical line and the x equals 3. That's just basically a way of saying do the derivative first. Once we get the derivative, we're going to plug 3 into the formula. So kind of similar to what I did some examples earlier with the product rule. Okay, once again, quotient rule. I'm just identifying who's the top function, who's the bottom function. Those are my f and g's. I do each individual derivatives. So now I've got my 4 pieces that I go back to the quotient rule and I plug my 4 pieces in the appropriate spots. This is what I get. Now, because I'm evaluating x equals 3, I'm not going to do the work to simplify this expression. I'm not going to do that algebra. I'm too lazy. Now, a good mathematician is actually kind of lazy because they're looking for shortcuts. They're looking for patterns. And so what I've got here is instead of doing the algebra, I'm just going to plug the 3 in wherever I see the x. Plug it into my calculator or the computer, let it crunch it all out, and there's my final answer, 144 over 25. And so that's my examples for the quotient rule. I hope they made sense. Just remember, when you're beginning, just do your calculations of the f and g's and the f primes and g primes off to the side, and then you can just take those 4 pieces and plug them in the appropriate spots here in the quotient rule. And so hopefully, once you get comfortable with, then you can start doing some more shortcuts and just doing things all at once kind of idea. But hey, take it easy at the beginning. Okay, this is Dr. Pat. You guys have a good day. Take care.